Hey everybody, welcome back to school. Sorry I'm not there with you guys. Um, I wish I was there, but here at home, taking a couple more days to take care of the baby. For those that um, don't know, I had the baby over Christmas break. He's healthy, he's fine. Spent about a week over in the hospital, and we spent a lot of time having observations and testing and stuff like that. So we're gonna take these next 2 days to make sure everything is okay and as much as I wish to be there, since I'm a new dad, I have these new responsibilities, and instead, we're going to learn about environmental science through video. This next topic is about energy, and obviously, if you haven't been living under a rock, you know that energy is a very important part of our world. Sorry. So anything that you use, like your cell phones, your cars, everything that you use every day uses energy. And the question is, where's all this energy going to come from? And when you guys are adults, or when y'all are adults, where's energy going to come from? And when it disappears, what are you going to use instead? So this whole section, I think it's pretty fun. To me, it was one of my favorite units, is about energy, types of energy and energy sources. So you should be given, or if not, be handed out a packet with these PowerPoint slides. We're just going to talk about the different types of energy. When I get back to class next Monday, I can show you some videos and some cool stuff, like how they actually make energy, like how does a nuclear power plant work and stuff like that. And some of you may be saying, oh, why don't we just watch an episode of The Simpsons, because they have nuclear power plants there, and maybe I could show you a part of The Simpsons. But yeah, I really like energy, and we're going to talk about it today. So first of all, in terms of energy policy, when anybody runs for presidency, they always talk about what's your energy policy, where do you stand on energy. There's usually two types of paths when they refer to policy. Sorry, I don't know what's wrong with you. One of them is called the hard path, which is basically what we're doing now. They say that let's find more fossil fuels and build larger power plants. So that's technically the hard way. We're going to do what we're doing now, but find more of it. The soft path, which is the way that most people don't want to do because it's more expensive and whatever, and it's better for the environment, looking for more energy alternatives that are longer lasting, that are better in quality and flexible. So the way that we should, or environmental scientists want, they want something that's integrated and sustainable. So you may be saying, what's integrated and sustainable? Integrated means that, just like integrated pest management, that means there's multiple ways that we're going to manage our energy. So no single energy can provide all the energy required by the world. So to provide our energy for our own communities, for our nation, integrated means we're not going to rely on just oil, or we're not going to rely on just solar. Integrated means we're going to use everything. And sustainable, we've talked about sustainable over and over again. It means that we're going to be able to use it. It doesn't run out, and it doesn't harm anybody, and that the future still has some energy left for it. And some of you may be saying, like, who cares about the future generations? We talked about this really briefly, so to review, there's a difference between high quality and low quality energy. High quality energy, we're talking about like electricity, moving on down like gas, coal, food. We're talking about energy that you can easily obtain and gives you lots of energy. That's high quality. Low quality, like low temperature heat, dispersed geothermal, sunlight and wind. Those are energy sources that are in low quality because it takes forever to get energy from them, and when you do, it's not that much. So high quality electricity, stuff that you know, or coal, gas, stuff that nuclear energy, stuff that you know, high velocity wind. Low quality stuff that it takes forever to get. You should know how energy is transferred. There's three types of transfers. One's called convection. Those of you that I taught marine bio may remember convection. I think some of you that took the marine bio class with the online marine bio class should remember convection. So think of it like you're heating water, okay, or heating a pot of water. Convection, this type of heating means when I turn on this pan and then I heat it up, this bottom part, or the bottom part of the water, gets really hot, right? And when it gets hot, it rises. And when that rises, it pushes the cold water down. And when that cold water comes down, it also gets hot and rises again. So we have what they call a convection cycle, where it's getting heat, it rises, it cools down and sinks, and over again. Also, that's how earthquakes in our plates work, something called convection. Conduction, sort of like dominoes. When I heat, this is sort of like the actual pan itself. When I heat the pan, this gets really hot. And when it gets hot, it pushes its neighbor to vibrate, and it gets hot. So it's like dominoes. This gets hot, and it travels all the way up and goes to the handle. So some of you that cook or have touched the hot pan before, you know that conduction can be really fast. And the last one is radiation. It's sort of like a subtle way of heating. So instead of the water being heated or the pot itself being heated, also the air around it gets hot because the water boiling and also from the burner, it radiates the air around it, and that's called radiation. So how do you know if something's efficient? The standard formula is power out divided by power in. Or long story short, think of it as like an investment. So if you're gonna put in a lot of, if you're gonna get a lot of power, you need to make sure that you don't put in too much power, or else it's not even worth it. Or if you're investing in a business, if you're gonna invest $1 million and the company only makes $1 million, then you're not making a very good investment. Same thing with energy. So a fuel cell like this, it has 60% efficiency, which means I only have to put in a little bit of energy and I get a lot out of it. Steam turbine, 45%. So these are the types. Some of you may have seen these two types of light bulbs. Some of you may have these two types at home. So just as an example, a fluorescent light or a CFL, or even like the coils. You may have seen like the little coils. That's 22% efficient, whereas an incandescent light, the traditional light bulb, is only 5% efficient, which means we're losing a lot of energy just to power it. Okay? And there's other ones as well. The first type of energy we're going to talk about is fossil fuels. They're forms of stored solar energy created from incomplete biological decomposition of dead organic matter. Whoops, sorry. Or in other words, it's fuels made from fossils. So like oil and gas, stuff like that, that comes from fossils. We've talked about it before in this class. So after millions and millions of years of fossils, eventually they compress and turn into oil, gas, or coal. So when we talk about fossil fuels, these are the three that you need to know. So crude oil, the one that you know probably most of, is naturally occurring petroleum. It's pumped from wells in oil fields. Some of you may remember a Simpsons episode where he did that. Some of you may have seen Armageddon, and there were oil drillers there. I want to show you, when I get back, a video about how they actually drill oil. It's pretty interesting. And then they refine it. Some of you may have seen the refineries. There's some in Carson where they refine the oil, and they make most of the petroleum products we use today. Some of you may think of oil as what we use to power cars, but also oil is used to make plastic. So the water bottles that you drink, or any type of the plastic bags, they're all from crude oil. Natural gas is naturally occurring gaseous hydrocarbon, generally produced with crude oil or from gas wells. So this is gas that's natural. You may have seen it on buses, like this is now powered by natural gas, or cars. And it's efficient in clean burning, and it's used in homes and industry. So natural gas is one that it's actual gas that is used for energy in general. So it burns cleaner. It's actually more efficient than oil. In terms of oil in the 21st century, you'll never guess which country is the worst in using oil. Yeah, us, or US. We depend so much on fossil fuels. Here's sort of like a pie chart. I could show you compared to the world, but 40% of our energy comes from oil. Or in general, 91% of the energy that we use every day, probably if you chart your life daily, 91% of the energy that you use every day is non-renewable, or it's never going to come back. But 9% of the world is powered renewably. So we're talking about hydropower, geothermal, solar, wind, biomass, all stuff we're going to talk about. If not today, I'll show you in the video tomorrow. So if you want to really show how the United States is really bad, here's 2008, we're talking about 3 years ago. Here's in thousands of barrels per day. Who's the biggest consumers of oil? The United States leads away with 19,498,000, so that's like 19 million barrels a day. And the next, number two, is China with only 7,000, Japan 4,000, and then we go into twos and the ones. So 19 looks pretty darn big compared to the rest of the world. I mean, you could add 11, 13, 15, 17. You could add up 2 through 7 and still get China, Japan, India, Russia, Germany, Brazil, and still get the amount of oil that the United States uses per day. This is the biggest importer, so not only are we terrible in using oil, but we also don't even get it from our own country. So 12,000 of the 19,000, 12,000 is imported from other countries. Where are the United States importing these barrels of oil? Well, the top oil producers and exporters: Saudi Arabia, Russia. We actually produce a lot. We're third. We never export it though. So if you look at this, we don't export it. But these are the countries, and you'll maybe notice where in the world these are. Okay, as you can see, it's very inefficient. So what's the effects of extracting mineral resources? Again, this is a review from the last chapter we talked about. You know, when we mine, we explore, we extract, we destroy the environment. When we process, and you can look at these pictures, and when we process, we put stuff into the air. I know this is autosaves. When we manufacture stuff, we create a lot of waste. So again, looking at these icons, then when we use it, they go into landfills, or in the case of plastics, or things that are not biodegradable, they last on the planet forever. So what are the what are the environmental effects of oil and natural gas? Well, in terms of recovery, we damage fragile ecosystems. Some of you already know that our ecosystems are they're very fragile. They barely last as it is. We pollute the air and the water, and when we waste, we have nowhere to put it. In terms of refining, when we talk about the refineries, remember I mentioned the Carson refinery. There's also one in El Segundo. Anytime we refine something, we have to pollute soil, water, air. When we deliver it, the energy is used to power automobiles, electricity, and lastly, the biggest effect that we've probably had in a while, and this has been updated since, but Prince William Sound, Alaska. You need to know this location and this story for the AP exam. It's the most damaging oil spill in history. So some of you may have heard of the Exxon Valdez. Exxon is if you haven't heard, is a gas or an oil company, and they they over a giant tanker transport oil over the Pacific Ocean. One day it crashed, and it spilled 10.8 million, 10.8 million gallons of oil into the water, which these are pictures of birds and seals, and all these different types of marine animals all died because of all the oil that was spilled into the Pacific Ocean. And that was this was back in, I want to say, 91, 92. Natural gas, this isn't in your slides, but I just wanted to share this with you. Natural gas, it's actually way better than oil. So it lasts 125 years. Oil is expected to run out in 50 years. So by the time you guys are, 50, 60 years old, you might run out of, or you will run out of gas, or run out of oil. Natural gas is made out of methane. Some of you may have heard of methane. It's most commonly associated with cow poop. And natural gas, it'll last really long, 125 years. You get a lot of energy. It doesn't cost as much. So remember, sometimes when we talk about the environment, how it's more expensive. This actually is less costing, less air pollution, lower carbon dioxide. Impact is not as strong as oil. You could transport it easily by pipe, and it's good for fuel, and it doesn't use much of the land. Some of you are saying, like, wow, natural gas sounds great. Why don't we use more natural gas then? Well, essentially, if something bad happens, it goes really bad. So first of all, when it's burned, it's a greenhouse gas. It can leak from pipelines. When it's shipped across the ocean, it's highly explosive. So the only way you could ship natural gas is in the form where it's explosive. And then sometimes you burn it off and you waste a lot because it's so cheap. It's like, I wasted a little bit. Who cares? It's cheap. But mainly, it's highly explosive, so it's really, really dangerous. Okay. The next energy source is called methane hydrates. It's an ice-like compound, and it's basically trapped in frozen water and deep in the sea floor. Almost think of it as like a hidden treasure in ice, and like you get this nice form of energy in an ice-like compound in the ocean floor. And we only have time left to talk about coal. Some of you may have heard of coal. It's solid, brittle. It's a carbonaceous rock. It's originally formed in swamps. Again, these are fossil fuels, so the fossils of animals that lived in swamps. It has carbon and sulfur content. It's mostly used for electricity. We have enough coal to last us 1,000 years, but it is the worst and the highest environmental impact. The reason why is because when we burn it, we put in a lot of mercury, and some of you know that mercury is terrible for you. Here's the types of coal. You just need to know the general, but you should know these names. Peat, which is and this is from youngest to oldest, so this is the youngest coal, which is not even a coal, peat. Going to lignite, then to bituminous coal, and then anthracite. And you could tell, because this is the oldest one, this is the one that's the highly desirable one, and the one that's not coal is the least. So the older you get, it's a fossil, the more energy that you get. Okay. We're going to run out of time, so I'll show you another video tomorrow. Take care, and I'll see y'all later.